Oh, thank you for coming to the deck.gl event. I'm here to talk about the WeatherLayers, which is a solution for weather visualization with deck.gl. My name is Jan Zak. We've talked during the past 2 days already with some of you. I'm software engineer by heart. Sometimes I'm consulting in topics around high performance graph and geospatial applications. It's both graph and geospatial because on the front-end side, it usually turns out it's constrained by the similar technologies, like going from SVG to Canvas and then to WebGL and soon WebGPU, of course. From my past, I'm connected with these topics like for tennis already. I used to be with GraphRare, which is a Neo4j consultancy company. Currently, I'm employed by IBM as a Neo4j team lead. And WeatherLayers is my side project, which is officially approved. So no conflicts here. But of course, whatever I tell here is not related to my employer. Then I'm the founder of WeatherLayers, which was founded sooner than the IBM started, because I was part of Manta company, which was acquired by IBM just a year ago. So currently we are like integrated into projects, but of course I'm not here to talk about it. If you want to connect with me, I'm with the handle Zakian on the usual social networks, Twitter, LinkedIn, and so on. WeatherLayers, what is it? It's a solution founded in Prague in 2020, and I like to abbreviate it as a weather visualization as a service, because it consists of 2 separate solutions, which can be used either together or separately, standalone, up to the customer how they want to combine it. The first part is WeatherLayers GL, which provides high performance interactive weather visualization layers and controls. And the second part is the WeatherLayers Cloud, which provides the data that can be used for visualization. And again, it can be used either standalone. Here you can see how the raw data is usually coming from the upstream sources, like it's a graded image of values, usually global, or it can be local. And the relay libraries to be provided in these ways. Now, a bit about the history. As I said, it's a side project. I'm a solo engineer. I do have a friend who's helping me with sales so that I can still focus on the technical topics, and it helps to bring more credibility on the sales calls, let's say. She will always start with chit chat and so on. So if anyone, if anyone of you has a technical side project and want to scale up, I recommend to hire a salesperson as soon as possible, or start with friends, and not hiring someone like completely unknown. Development has started in 2020 as layers for Mapbox and implemented with GDL shell commands. It started as already with a customer in mind, because I used to be freelancing in that time, and the customer connected with me on Upwork. So this is how it started. And then I discussed with them a lot that I'd like to continue with the project on my own and serving more customers. That was approved. So in 2021, I founded a company. I have applied to Cooperative Masters Challenge in 2021, and I won the Czech round of the challenge. I was in the Global European round as well, but not yet there. I applied to ESABIC, which is an incubator for space startups, let's say. The application was declined because I was a solo engineer, and they were looking for larger teams, of course. So then I didn't give up. I rewrote the solution from scratch to deck.gl and Rasterio, because the Mapbox solution, of course, worked. But there were potential customers that were interested about how to connect it with their existing application, which used leaflet or open layers, for example. So it showed very quickly that it's very limiting to have a solution only for a single library. And that's how I became more interested about deck.gl, because it actually provided this promise of being able to have a single implementation for rendering and to be able to integrate with different base map libraries. And the GDL solution with Shell, that was very unscalable. It relied on Chrome downloading the data every time. And when I reworked it to Rasterio and Python, it became much easier to scale it in the cloud. And yeah, then in 2023, deck.gl 9 happened, so that took some time to upgrade it, and of course TypeScript. I actually used JS doc annotations before that, so the migration to TypeScript was pretty painless, but I brought some more issues up. At least that was successful. Now a bit of a sales page. The customer's benefits of the solution is that it provides the ready-to-use solution for interactive visualization. And the real advantage is to be able to allow customers to overlay their custom geospatial data together with the weather context. So for example, if there is an application showing the airplane positions or vessel positions on the sea, or power plants together with the wind speed data, which can show how the power plant wind power production increases with high wind and so on. So it really helps to put the data with the concept into the context with the natural environment around. And of course, customers could open two applications side by side. Let's say, for example, windy on the left side of the screen and on the right side of the screen, their own data. But this kind of integration really helps to have the timeline synchronized and the viewport synchronized and everything. Then the library supports real-time customization so that all the configuration options are built into GPU controls, like for example, the colors. There's a color map provided to the library, so it's not pre-rendered on the backend side. Like if you look into old weather solution, they usually render the images on backend, so it's not easy to actually change color. And compared to other solutions, I'm focusing on seamless user interaction. So it will be visible in the demo, but when I zoom in or zoom out or move with the map or even pan the map and how is it called? Angle the map or rotate the map. The particle positions, for example, they still keep animating, and the other solution they usually just reset the animation because it's easier to do it this way. And of course, I'm focusing for the developer experience for low integration effort because my customers are not the end customers, but the companies that have their own software team and they want to integrate as quickly as possible. As part of the solution, I provide the maintenance support and upgrades, and for the cloud service, it provides the data, of course. Now, a bit about the references. On the left side, there is Australian beach erosion and coastal flooding early warning system, which was built with the collaboration of University of New South Wales. And it's actually a good use case of custom data because they are doing their own data modeling. So it's not public data at all. Unfortunately, when I looked yesterday, whether it's online, it seems to be down. So I'm not sure if it's down permanently or it just moved somewhere else. I need to catch up with them. In the middle, there is Watch Duty wildfire monitoring application for the US West Coast, and they are using the data and the particle animation because this is where the wildfire is moving, right? And on the right side, this is a very popular application built by Robin Hawks, which some of you may know from because he helped with Unfolded as well. And this application is showing exactly these are wind power plant positions and how much energy does it generate in the areas of high wind and how low it's in the area of low wind. It was very popular on Twitter like a go, and he actually helped me a lot with the promotion in the time. So even if he's not here, thanks. Yeah, there are many other customers. From UK, I have Maritrace, Meddesk, and Octopus Energy, which some of you may know. Maritrace is the vessel monitoring. Meddesk is a solution around weather. Octopus Energy is a renewable energy provider. It's a lot of maritime and lots of maritime. I know AI is similar to Watch Duty. It also provides solutions for the wildfire monitoring and so on. Now, a bit more to the technical topics. WeatherLayers GL, it's a commercial license. It has a perpetual license, which came to be bought on one-time payment. And there is an optional yearly support subscription, so that whenever a customer buys the single version, he gets 1 year of support, which gives him the way to use the library using the version that was available during that year. And if they want to continue using the upgraded versions, it's necessary to continue with the support. But in case the support expires, then the library still continues to work. So it's not like I would be trying to force the subscription. And this way of licensing is inspired by commercial graph libraries, where it's quite common, because when they have like these technical cases that needs to have a lot of technical experience, and they just want to, the customers just want to integrate and don't care about like with graph fibers, you have the graph layouts, it's force directed and so on. So there are WAV files of marginalized React flow that's used in the Chris's demo, right? It's all similar cases. It's possible to have a commercial front-end library. It's not easy, but it's possible. The difference from deck.gl is I see it as it's similar to GDAL versus OGR, because I see that deck.gl focuses a lot on vector data, and this is how it started from Uber with traffic data or something like that. Except for bitmap layer, of course, but WeatherLayers focuses on raster graded data, which is provided in the raw data form. It's a grade of latitudes and longitudes and the values at that particular position, like what's the temperature in London, for example, at 0 to 0 or 0. I don't know what's the latitude here. In WeatherGL, there are 5 layers at the moment. It's the raster layer, which provides the visualization using colors. There is the particle animation layer, which is very popular since it was, I'll talk about the history more later. There is a contour layer, which is just a different way how to display the raster, but with contours. You've seen it on Felix's demo yesterday as well on the SDF. Right? And then there is grid layer, which basically shows the values at particle positions at the grid. Island low layer, it's quite interesting, but the use case is very limited. It shows the lows and highs for the atmospheric pressure, which is calculated on the CPU at the moment. Should investigate how to do it on GPU. And front layer, that's for displaying the weather fronts, which unfortunately can't be computed with the raster-graded data. I haven't found the way yet, so it relies on the customer providing their own data source for the weather fronts. There are also controls. There is a legend uses the same color map as the layer. There is tooltip control, which when the user moves out with the mouse, then it shows the current value under the mouse. And there is timeline control, because usually the weather data is coming in a form that there is data for the current date time and there are forecasts, so users want to animate that stuff. What's interesting about the timeline is that when the data is it's available in discrete moments, like every hour or every 6 hours. So even if it's discrete like this, it's possible to interpolate 2 images together using the timeline so that it looks more smooth for the user experience. About the accepted format, it can be any typed array data, like uint or float32. It can be even offline data. So this way, I support that the WeatherLayers GLab can be really used standalone, because the data can be just passed in as a typed array. And there is no support for tiling at the moment, because it turned out, of course, tiling is perfect in deck.gl because lots of data can be detailed. But in case of weather data, I actually haven't seen a use case for tiling yet, because files are very, very small, and I'll talk about it next slides. So for now, it's just single sites. And just interesting note about the support as part of the upgrades. Just recently, I've seen that with Chrome 1.2.8, current Chrome stopped accepting NAN uniforms. So if you are passing NANs to your shaders, you'll need to replace it. And fortunately, this was raised by one of the customers that I have because they are testing it on testing Chrome version, so it was caught off quite early. And then I was notifying every customer that have the support subscription, hey, there is this new version, so you should upgrade. WeatherLayers Cloud. Sorry, is there a question?
Yeah, we did that 2 weeks ago.
Yeah. Oh, nice. So that was around the same time.
Well, we didn't know about this until 10 seconds ago. So.
Oh, okay.
And then we added code that was doing this a few weeks ago.
Now we are future-proof. About the WeatherLayers Cloud, again, as I said, it's separate. The pricing is as a yearly subscription there, because that's clear. When the user consumes the data, they need to pay. If they stop consuming, they don't need to pay anymore. And for simplicity, there is just a single plan because we didn't have capacity to implement any rate limiting or multiple plans, like depending on kind of data are they interested in. Right now it works. Cloud service is providing the weather data for the visualization from publicly available data sources like NOAA or Copernicus. And the real benefit of this solution is that when you start looking into how the weather data are provided, it's usually various inconsistent interfaces and formats can't be consumed by the end user browser directly. Like sometimes it's on FTP, sometimes it requires to use even a custom Python library, in the case of Copernicus. And the formats is grep and netcdf, which in theory might be readable in the browser, but the libraries are outdated, and I'm not sure if I would recommend anyone to rely on them. It would be interesting to start looking into it. It's possible to parse them directly from the browser, but these formats are not even made for, they are not cloud optimized, so it's necessary to download the whole file. And all the data sources are published as a stack. That's spatial temporal asset catalog. If you are following this topic, then it became quite popular over the past 2 or 3 years, I would say. So basically, I'm providing a consistent interface across different data sources so that it can be consumed by a single client library. Now, how it works under the hood, the cloud service is basically a caching proxy, which whenever user triggers a request, hey, I want to see what's the wind speed today, then it goes to the upstream data source, downloads it, processes it, and returns back as PNG or WebP or GeoTIFF, whatever is requested. And there is also no archive. It basically depends on the upstream data sources. The benefit of this kind of architecture is that the cost for running it is very low, because previously when I was downloading with Chrome, and I was downloading lots of data every 6 hours or every hour, and the costs were unbearable. So with this solution, the cost really correlate with the usage. The disadvantage is, of course, that when the data is not cached on my side yet, it takes a bit more time to download it, which is fine for NOAA. It's on S3, but for Copernicus, it can take up to, let's say, 20 seconds roughly, or even more if there is a customer requesting the data for the. So there is, of course, a question of adding the cache warm-up, which is not implemented yet, but it might be there eventually in future. And there is an overhead of the account management, like creating access tokens and properly enforcing it. Now, when someone uses the WeatherLayers GL and cloud together, then the formats supported provided by cloud is PNG or WebP in 8-bit, or there is GeoTIFF with float 32 for compression. I was investigating a lot about potential compressions that can be used with GeoTIFF for float 32, because it's better to have the raw data, but it turned out that for the visualization use case, the 8-bit quantization or compression, as in the quotes, even though it loses details, it's good enough for raster visualization purposes, because it's more important to see the patterns and not to have the actual exact value. So they are both ways supported. The disadvantages of 8-bit is that it requires the unscale bounds, like minimum and maximum value, to be defined upfront for each data set, because temperature has a minimum of something like 200 kelvins and maximum 350 kelvins, for example. It's wind speed, of course, has different minimum and maximum. So the PNG image itself is not enough because the metadata, like the min and maximum values, need to be provided separately. And this actually nicely correlates with yesterday's topic about loaders GL, the split between loaders and services. So I believe this could be a service because there is a metadata necessary to be provided before the actual rendering can start. And regarding detailing, the reason why detailing is not necessary is that NOA GFS file with 0.25 degree resolution, it's 1440 times 720 points, and in PNG it's compressed to 0.5 megabyte. So why hassle with tiling?
But when you zoom in,
Sorry?
What happens when you zoom in?
Then it overzooms. It's still the same image.
Pixelates.
Well, it pixelates if you have the nearest interpolation, and there is a configuration option I will show you in the demo that allows to select either linear interpolation or even a cubic interpolation.
So it only requests the image once. It doesn't request a new image.
It's still the same image.
There's no data like a higher resolution.
No, it's still the same image.
So that's the whole world.
Yeah, whole world. It's the image that I was showing here in the beginning. This is the whole world, 0.5 megabyte.
So it's around 0.2 degrees per pixel?
0.25 degrees per pixel. Yeah. Demo?
5 minutes for the demo.
5 minutes, okay. Am I so slow? Okay, I should speed up then. So when you go to the website, there are two links how to get to the demo. Here is through the demo page, which lists to the particle data sources, or I can go through the integration page, which lists the particle integration that are supported, and I'll go to MapLibre interleaved. Okay, now you can see that it animates the wind speed. I can rotate it, pan it, and it still keeps animating. When I zoom in, for example, in here, you can see that it's interpolated, and I'll turn off the grid layer. It's not that confusing. When I make the interpolation nearest, then you can see that. Oh, is it visible? Yeah, there is an edge, right? So this is the nearest interpolation. There is linear and there is cubic, which is the most smooth, but of course it requires more pixels to be accessed. Oh, yeah, since we have little time for the demo, I guess I'll stop it and continue. But if you have further questions, then I can definitely show it afterwards. And feel free to explore the demo. It has lots of configuration options. Don't be intimidated. It's made for the developers, so everything can be turned on and off. One feature that I would like to show is the pressure layer, just before I finish the demo. And I reload it so that it's again like this. The pressure layer shows the contours, which is rendered from the raster. And actually, when I was implementing it, Felix was providing useful hints, so thank you for that in the time. And I can zoom it in and zoom out, and you can see the contours are smooth. It's not vector, it's raster. And this year, earlier this year, I was setting support for color for the color palette everywhere, so I can even color the contour with palette, or everything can be colored by the palette, basically. Now going back to these slides, and I need to be real quick then. Sorry, I lost track of time. Integration promise of deck.gl is really what drove me to deck.gl in the first place. All of this. What's good is that MapLibre and Mapbox, they both work well. The only unfortunate thing is the globe, and this is going to be like a constant topic. I'll keep reiterating in further slides. Mapbox Globe is apparently missing necessary APIs, and MapLibre Globe is upcoming. So I would be really interested to see if there is any chance to see this kind of integration. And of course, I would benefit from it naturally, but it would benefit to the entire community because lots of customers are asking, we want to have a Globe, right? And there, on my side, there was just a recent fix that I used to have issues with particle animation flickering that wasn't replicable very well. It used to happen more in React than with Vanilla.js integration. And just recently, I found out that transfer feedback is drawing somewhere where it shouldn't be, into dev buffer, into stencil buffer, and it helped to turn everything off. So I should probably create a pull request for this to fix to upstream. For me, it was enough to turn this off. Leaflet, there's the historical most popular library of the time. I still see it as an entry point for newcomers to geospatial. There are still potential customers coming to me that already have Leaflet application, and they are asking about how we can put the weather into it. So that's why I actually created the deck.gl Leaflet library to provide a way how to integrate with Leaflet easily. And it's still up to me to move it to the deck.gl community, which is in plan for a longer time. It just didn't happen yet because of low capacity.
There is a recent issue about that leaflet
Really?
example not working.
Okay, I should have a look. Thanks. Or if you can send me a link.
Yeah.
Thank you. WeatherLayers, it's another non-WebGL based map library, which currently doesn't even have an integration library, and I'm not sure if it's actually necessary because Sharon, I think you've created it or someone, it's just a piece of code that combines these two libraries together, right? It's on the official GL website as well.
We have a getting started example.
Yeah, or someone contributed it. I'm not sure. It just works and no library is necessary, it seems. Now, with the other libraries, it gets a bit more complicated. Google Maps, the support has recently improved thanks to the Carta and Google collaboration, and thanks Felix for that. Overlay mode works, and the interleaved mode, for me, it has the issue that there is still, when there is a repeated words, then you can see that how it blends together because the layers are it's rendered multiple times for some reason, and apparently it's back on Google's site and they haven't followed up on it yet. That's how I understand the issue.
This has been there a long time.
Yeah, and Globe, there is, sorry, what's that? Yeah, Globe. There is Globe in Google Maps, the official version, but it's likely disabled in Google Maps.js, so it's not a topic yet. ArcGIS.js, again, overlaid mode works. Interleave mode has a blocker issue on my side. It flickers during the animation, but this is likely on my side to fix. And the globe, I tried to fix the ArcGIS module in deck.gl to find out how to integrate with deck.gl, and there is still like a draft PR that hasn't been finished yet by me because I haven't been able to find out how to connect them together properly. Apparently, this globes topic is more complicated. Like there can be multiple different globes implementation. It's not that easy as with the Mercator, right? Cesium, it's another popular globe, but again, there is no integration. So the only way to integrate for me is to provide a static raster image. That's all. And lastly, Apple Map Kit. I don't know at all. It has been published just recently, so we'll see. Now, I have a question. This is a share of map libraries for my customers. Which one do you think is the first one?
Leaflet.
No.
Not Cesium.
Sorry?
S3.
Not Cesium.
No Cesium. What did you say?
S3.
S3? No.
Mapbox. One.
Mapbox. Yeah, exactly. It's Mapbox. And despite the fact that MapLibre is now open source, right? It's still Mapbox. So we have Mapbox the first, MapLibre second. Together they are like 60%. Then there is ArcGIS for me because for historical reason I was providing. I'm providing just the data, and on the ArcGIS side, it's rendering the static image. So this is the way how the integration works. And then with the similar ratio, there is deck.gl itself. below, Leaflet, WeatherLayers, and Google Maps. So, summary about the integration. The advantage is it provides the promise of single rendering of all supported base map libraries. Of course, the disadvantages is that it's tricky to have the camera control and viewport in sync and mouse event propagation, and each base map library has its own issues. So I understand that it's not that easy to have everything supported. Then all these integration are still with the Mercator projector only, no globes. It's a pity, but I don't have any capacity to help with this, and it's more complicated topic. Sometimes it's raised to me that the deck.gl text rendering is different from the base map. So actually, it's different rendering, but it's more the most visible with the text. There are rough edges and something like that. And of course, whenever customers have their own application already implemented with Mapbox or Leaflet, usually they don't like bringing deck.gl as another bundle size increase. So, well, when I tell them it's the only way they are fine with it. Now, there is a lot of similar solutions. I'll not go through them one by one, but you can see that the solution for wind particle simulation, it's been here with us for a longer time in the past, which started with this image created for an art exhibition in the US. And then there were multiple solutions in the past. Then after here in the middle, there is a gap. And this is exactly where I started working on this solution. Later, more new solutions have appeared, so you can see that the space is quite crowded already. Now, there is a question about open sourcing it, of course. I was thinking about it in the beginning, but I used to be an open source maintainer of a few small projects, and of course, you know, the fatigue when people start asking questions and you don't have capacity for that, but you feel obliged to actually start doing something about it. So I wanted to try to do it somehow differently, and that's why it started as a commercial project since the beginning. Another reason is that consulting doesn't scale, because consulting, it still depends on one person's time who provides the consulting. So I wanted to try to build a whole product. As of now, it's good that the funding is secured for the development by the B2B licensing. So there is some stream of money allowing me to work on it from now on, like as part of the side project. And to be able to support like non-commercial use cases, like for the wildfire monitoring, there are non-commercial plans available. Now, parts of the WeatherLayers are open source, and I'm definitely open to discuss like a few further changes in them, like relicensing to MIT or moving them to a deck.gl community, like the deck.gl leaflet library. And regarding the WeatherLayers GR itself, then I was considering to split it to free and pro version, but the issue there is that it doesn't seem to be worth of the complexity, like to have these kind of two bundles together and still being able to control it, what's in the pro version and what's in the free version. And actually, there is not that much features that I could have only in the pro version, so it doesn't make much sense to me. I'll make one prediction for the future. Similar as base map rendering has been commoditized with Leaflet and Mapbox, MapLibre these days. I believe that with more environmental use cases, we will see that weather rendering will need to commoditize itself as well. And even though we see there are multiple commercial providers, it's mostly about the data, and the rendering can be consistent using deck.gl. So for me, the way to go there is I'll need to rebalance WeatherLayers focus to the cloud service and to providing the data. And the reason for this is that when you look at this share on the top chart, you can see the current customer count for WeatherLayers GL. The middle is both combined together, GL and cloud, and this is the cloud only. So you can see it's mostly GL, and cloud comes like part of the solution. It may be necessary, but it still comes from the GL. And actually on the second chart, you can see GL is most of the revenue. So what I need to do is to shift the cloud revenue to be larger than GL, and then the GL open sourcing can happen. What's next? For the GLA library, of course, all layers, I will need them to support UBOs and shader modules and web GPU shader language. For the particular, currently it's implemented as transport feedback, so that goes for the compute shader that will simplify the layer quite significantly. For control layer, there is a frequent request because customers are used from static weather rendering that they have these nice labels on the contours. Because the contours are not vectors but rasters, then it's an ardent topic on my side to find out how to support it well. Because of course with vectors it's easy. If I pre-compute the vectors and then I can put it into Mapbox render line and it shows nice labels together, including the conflict resolution. So I need to find a way how to support it with the raster data. Then controls, I'll need to rewrite them into the GL widgets because there are some requests about how to improve the styling flexibility. And especially on the cloud side, there are always requests for adding more data providers like NOA, HRRR, which is data source focused on the US only, not global. ECMWF is, it used to be focused on Europe, I think, but also it is still a commercial data source, but recently they have published some data on the global level already. So some customers are already asking about how to integrate it. Australian Bureau of Meteorology, so on. The reason why it's not added yet is because it's always a single customer asking for it, and it doesn't seem worth adding it, but it may be necessary. And actually, with the on-premise deployment and configurability, this is where I will need to shift the focus on, because so currently in the cloud solution, for example, there is no cache warm because every customer would need their different data to be warmed up. So it doesn't work well with my goal of making the cloud solution costs low. Like currently, it's like 300 euros per year because it's accessing publicly available data. It just doesn't feel right to charge more for it. So this is only to keep the server's costs. So this is where I believe I will need to focus. To package the cloud solution for on-premise deployment in a Docker and provide configurability so that each customer can configure, hey, I want to cache HRR, for example. And for the deck.gl, my wish list is that these three pieces, core visualization features, single rendering of 4 libraries, and platform for commercial base map providers to support integrated with, this is already supported. I like that deck.gl provides like the strength to be able to negotiate, for example, with Google Maps. That's perfect. Web GPU integration is coming. My only wish is about globes in any base map library and about mobile, because currently if there are customers asking how to integrate it with mobile applications. So currently the only way is with a web view, which works well, but still sometimes they have an application with React Native, for example. And even though there is this deck.gl native experiment, I know that it's only an experiment and it's not supposed to be for any production development. So I will be interested to hear if there is anything upcoming in this site, or if anyone would be doing anything about it. But not me, because I don't have any knowledge about mobile development. That's unfortunate. And that's all from me. And just a small piece before I say thank you. If anyone would be interested about helping me with some of the topics, then I'm open to hire. I am hiring. That's it.
You said about open sourcing model. What about I don't know, non-commercial free license or stuff like that as a solution for?
Yeah, this is possible. Usually the non-commercial case depends on the use case, but some of the licenses are even for free. It really depends on the use case. Like for example, for the GB renewable map for Robin House, one was for free. I do provide also free license for, how is it called, the Ukraine monitoring application. How is it called? State map. Yeah. So this also has a free license from me.
Like the globe view in MapLibre,
Yep.
it's contributed by people from the Czech Republic, actually, also like Windy, right?
Okay.
I think they are based in Czech Republic.
They are.
So and they also do these wind visualizations, right?
Yeah.
And they are doing the globe in MapLibre because they want to switch to MapLibre.
Okay.
Yes.
Okay.
And so, like, once there's a globe in MapLibre, what do you think needs to happen for you to use it? It has to also be
Integrated with deck.gl.
then you're good.
Yeah.
Okay.
Exactly.
Let's see. Because I think what they are doing is they are using the custom layer interface in MapLibre.
Yes.
Yeah,
I
yes,
think-
direct.
I think they implement their own custom layer.
Yeah.
Canvas based.
For
Yeah, currently Windy is canvas based, and that's where you see that when you zoom in and zoom out, then the particle rendering resets. So that's why it's visible. It's kind of canvas based solution. And I do have Windy mentioned here down there in standalone application, but it's not really like a competition to me, or because it's B2C. Like they explicitly are saying they don't want to have any B2B use cases. I have. So it's similar solution, but different target markets.